Welcome to the DIY Honda Garage channel. The Honda CR-V 2023 Plus has encountered DTC P26E4-9E, indicating a problem with the starter cut relay diagnosis circuit due to low voltage. This means the system responsible for ensuring proper power supply to the starter cut relay is not functioning as expected. When the engine is off, the Powertrain Control Module, PCM, monitors specific input voltages to detect abnormalities. If the voltage from the starter cut relay diagnosis line drops below a specified threshold, the PCM registers this issue and stores the diagnostic trouble code DTC. Understanding this DTC is essential for diagnosing starter-related issues and ensuring the engine operates reliably. Diagnosis and repairs should be performed based on the specific manual guidelines and steps provided in the Honda servicing materials. The DTC P26E4-9E refers specifically to the starter cut relay diagnosis circuit experiencing low voltage readings. This circuit plays a critical role in controlling the power supply to the starter, enabling or disabling it as needed. Situated within the vehicle, the relay is connected to the PCM, which is responsible for monitoring its status. When the starter is in the off position, the PCM looks at the voltage from this relay circuit. If this input voltage drops below an accepted level, it signals that the starter relay circuit may be compromised, leading the PCM to store this trouble code. Early detection of this error helps in mitigating further potential issues with the starter assembly, ensuring effective vehicle operation. There are several potential causes behind DTC P26E4-9E. Firstly, a defective relay circuit board could prevent the starter cut relay from functioning properly, leading to low voltage readings. Additionally, wiring issues, such as a shorted wire between connections ST-RLY1 to 2 and ST-CUT-RLY2CL, may disrupt the electrical flow necessary for accurate voltage inputs. Another significant cause could be a malfunction within the PCM itself. If other components in the circuit are operating correctly, but the DTC persists, it may indicate that the PCM is at fault. Identifying these issues early can prevent larger problems with starting the engine, thus enhancing vehicle reliability. When DTC P26E4-9E is present, several symptoms may occur during vehicle operation. The most immediate symptom is that the engine may not start at all, signaling a potential problem with the starter cut relay or its circuit. Additionally, intermittent starting issues might be observed, where the engine starts sometimes and fails to start at other times, leading to frustration. This unpredictable behavior may also include electrical system alerts on the dashboard, indicating that there is a fault within the starting system. Recognizing these symptoms early is crucial for timely diagnosis and repair, ultimately ensuring the vehicle remains dependable. The first troubleshooting step for addressing DTC P26E4-9E involves attempting to start the engine. This initial attempt can provide immediate insight into whether the starter cut relay is functioning effectively. Next, transition the vehicle to the off lock mode to reset any temporary electronic faults that might influence the circuit's functionality. Following this, switch the vehicle to the on mode and wait for at least 5 seconds. This step allows the PCM to recalibrate and recheck the voltage reading from the starter cut relay diagnosis line. This systematic approach helps in confirming whether the low voltage condition persists and aids in identifying the source of the fault. In the second troubleshooting step, the focus shifts to testing the relay circuit board. This component is critical for controlling the starter cut relay, and any defects here could lead to low voltage readings. Begin by performing diagnostic checks as indicated in the service manual. which may include inspecting the relay connections and any visual damage. Ensure that all connections are secure and free from corrosion, which can hinder electrical flow. If the tests indicate failure, this would suggest that replacement or further inspection of the relay circuit board is necessary. By isolating the relay in this manner, you can efficiently determine if this component is the source of the issue before exploring other options. The next step in the troubleshooting process involves inspecting the external circuits, specifically checking the wiring associated with STRLY12. This inspection is vital, as shorts or breaks in this wiring can lead to low voltage readings, signaling an anomaly to the PCM. Begin by reviewing the wiring for any visible damage or wear. Additionally, use a multimeter to check for continuity and resistance in the wires, ensuring they exceed the minimum values required for proper operation. If abnormalities are detected during this inspection, repairs or replacements may be required. Conducting this inspection systematically will help eliminate wiring issues as a source of the DTC. In the fourth troubleshooting step, a comprehensive PCM inspection is performed if previous steps indicate normal conditions in external components. The PCM, or powertrain control module, serves as the brain of the vehicle, making decisions based on input from various sensors and relays. If the relay circuit board and wiring have been tested and found to be in good condition, it's feasible to conclude that the PCM itself may be at fault. Analyzing potential failure within the PCM involves checking diagnostic data and ensuring that all inputs are functioning correctly. If no issues are found with the relay or wiring, and DTC P26E4-9E remains active, replacement or reprogramming of the PCM may be warranted to restore normal vehicle operation. Final repair verification is crucial after completing the troubleshooting steps for DTC P26E4-9E. First, clear all DTC codes from the PCM to reset any logged errors. Next, conduct a test drive of the vehicle to evaluate how the repair has impacted starting functionality. During this test drive, pay close attention to the vehicle's electrical systems and starter responsiveness. If the vehicle starts smoothly without issues, return to the diagnostic tool and perform a final series of checks to ensure no new codes appear. This thorough verification phase ensures that the repair was successful and that the issue has been permanently resolved. Preventive maintenance plays a significant role in averting future occurrences of DTC P26E4-9E. Regular system inspections can identify wear and tear early, thus allowing for timely repairs before they escalate into larger issues. Utilizing quality replacement parts, particularly for the relay circuit board and wiring, ensures durability and functionality, preventing recurrence of low-voltage conditions. Moreover, maintaining vigilance on electrical connections and their condition can significantly reduce the likelihood of shorts or other malfunctions. Simple practices, such as checking battery terminal connections and inspecting relays, can help safeguard the vehicle's starting systems. Implementing these preventive measures greatly enhances long-term reliability and performance. In conclusion, addressing DTC P26E4-9E requires a structured approach to troubleshoot the starter cut relay diagnosis circuit effectively. The primary driver for this DTC is low voltage conditions, which can stem from defective components, wiring issues, or a malfunctioning PCM. Systematically isolating and verifying each component is crucial in accurately diagnosing the root cause of the problem. Following up with routine maintenance practices will also be essential in preventing future DTC occurrences. By committing to thorough inspections and recognizing symptoms early, you foster a reliable vehicle performance while prolonging the life of the components associated with the starting system. Please like and subscribe to the channel. See you next time.